Hello everyone, my name is Vivek Nagle. Now I am going to present my topic Big Data and Privacy Prevention. Now we will going to understand what is data. Data is information usually in the form of facts or statistics that one can analyze or use for further calculation. Data is different types of information usually formatted in a particular manner. All software is divided into two major categories, programs and data. We already know what data is now, and programs are collection of instructions used to manipulate data. We use data science to make it easier to work with data. Data science is defined as a collection that combines data, knowledge of mathematics, programming skills, domain expertise, scientific method, algorithm, processes, and system to extract both structured and unstructured data, then apply the knowledge gleaned from that data to a wide range of uses and domains. Now, we will understand what is the meaning of information. Information is defined as classified or organized data that has some meaningful value for the user. Information is also the processed data used to make decisions and take action. Processed data must meet the following criteria for it to be of many significant use in decision making. First, accuracy. The information must be accurate. Completeness. The information must be complete. Timeliness. The information must be available when it's needed. Now, uses of data. Growth in the field of technology, especially in the smartphone, has led to text, video, and audio is included in the data plus the web and log activity record as well. Most of the data is unstructured. Now, we will understand what are the three types of data. Data are of three types: structured data, unstructured data, and semi-structured data. Structured data. Structured data conform and associate with data schemas and data models. Simply, we say the data that are capable to store in a relational database tables in the form of row and column is called structured data. Nearly 15 to 20% data are in structured or semi-structured form. Now, what is unstructured data? Unstructured data does not process data features such as a table or a database. The most simple example of unstructured data is audio or video that are uploaded and downloaded in a YouTube and other sources. Semi-structured data. Examples of semi-structured data are XML and JSON documents. Semi-structured data contains text or other markers which separate elements and input hierarchies of records and fields within the data. Now we will discuss what is big data and which type of data we call big data. Now the big data is used in the data definition to describe the data that is in the petabyte range or higher. Big data is high volume, high velocity, and high variety information. Asset that requires new forms of processing for enhanced decision making, insight discovery, and process optimization. Big data is also described as five ways: variety, volume, value, veracity, and velocity. Nowadays, web-based e-commerce has spread vastly. Business models based on big data have evolved and they treat data as an asset itself. And there are many benefits of big data as well, such as reduced cost, enhanced efficiency, enhanced for the processing of the big data. We require some special types of tools like Hadoop, MapReduce, Spark, Flume, Zookeeper, etc. Because we cannot process big data with the traditional tools because the capacity of storage and the volume of a big data that is generated day by day is in the million, like 250 million times greater than the simple data that we generate. Big data, big data is a collection of data that is Big data is a collection of data that is huge in a volume yet growing exponentially with time. It is a data with a so large size and complexity that none of traditional data management tools can store it or process it efficiently. Big data is also a data but with a hug size. The meaning of data has grown beyond the processing of data in the field of computer application. For instance, we have already touched upon what data science is. Accordingly, finance, demographics, health, and marketing also have different definitions of data, which ultimately result in different answers to the query. How is data, big data processed? Big data are processed using Hadoop, in which the data is distributed in a form of a cluster using a Hadoop distributed file system in which we have some processing framework called MapReduce. MapReduce doing the work of mapping the data and combine the data using the reducer and give the final output of the data after the processing. Now we discuss what are the examples of big data. Following are some of the big data examples like the New York Stock Exchange is an example of big data that generates about 1 terabytes of new trade data per day. Social media, the very important and very useful examples of big data is social media. The statistics show that 500 plus terabytes of new data get ingested into the databases of social media site Facebook every day. This data is mainly generated in terms of photo and video upload, message exchanges, putting comments, etc. A single jet engine can generate 10 plus terabytes of data in 30 minutes of flight time with many thousand flights per day. Generation of data reaches up to many petabytes. Now, the five pillars of big data each: volume, variety, velocity, variability, and value. Now, what is volume? The name big data itself is related to a site which is enormous. Size of data plays a very crucial role in determining value out of data. Also, whether a particular data can actually be considered as a big data or not. Simply, the meaning of a volume is the amount of generating the big data by the organization. Variety. The next aspect of big data is its variety. Variety refers to heterogeneous sources and the nature of data, both structured and unstructured. During earlier days, spreadsheets and databases were the only sources of data considered by most of the applications. Nowadays, data in the form of emails, photos, videos, monitoring devices, PDF audio, etc. are also being considered in the analysis application. This variety of unstructured data poses certain issues for storage, mining, and analyzing data. Velocity. Velocity is the speed of generation of the data. How fast the data is generated and processed to meet the demand determines real potential in the data. Variability. This refers to the inconsistency which can be shown by the data at times, thus hampering the process of being able to handle and manage the data effectively. The five V's is value. In value, in big data, we assign some value so that the organization can trust to the data that the data provides the information is correct. Now, the advantages of processing big data. Processing of big data has so many advantages. Uh, for example, an organization interested to know how many users visit to site and how what are their feedback after visiting the site. So they are required to analyze the data, and the data is in very large amounts, and the storage of data is large, so we can found our required result using the processing of big data that we want. Advantages of processing big data. Ability to process big data in DBMS brings in multiple benefits, such as businesses can utilize outside intelligence while taking decisions. Access to social media from search engines and sites like Facebook, Twitter are enabling organizations to fine-tune their business strategies, improve the customer service. Traditional customer feedback systems are getting replaced by new systems designed with big data technologies. In this new system, big data with natural language processing technologies are being used to read and evaluate consumer responses. Now, we will understand what is data privacy and why it is important. We are in the simultaneously wonderful and horrible situation where our data is being both actively collected and processed. What does this mean for consumers? Mega corporations are collecting, storing, using, and in some cases, selling data about you without your permission or with permission buried so deep in a user agreement that you don't even know you have agreed. Moreover, unless you want to live without the services they provide, there is not a whole lot that can be done to stop this organization. Given how the system is currently designed, even if the data sold is sanitized, it is often not enough to protect your privacy. Data value. Your data has value to your organization and third parties. The data was expensively obtained. It represents a valuable asset on which a return must be generated. Similarly, third party data can be used to augment your data to increase its value. To achieve the value inherent in the data, you need to be able to make it appropriately available to others, both within and outside the organization. You need a process that enables you to make your data available as widely as possible without exposing you to risk associated with non-compliance with the wide range of differing data privacy regulations. You need a common approach and framework that work for all data sharing while guaranteeing legislative and regulatory compliance. Data prevention is the removal of personal identifiable information from data. At a very high level, data prevention can be achieved in one or both of two ways. Data summarization. Data summarization is the set of individual data records are compressed into summary statistics. Data tokenization. The personal data within a data set that allows an individual to be identified is replaced by a token. Or reversibly, the concept of risk is at the core of data protection regulation and legislation. Appropriate technology, appropriately implemented and operated, is a means of managing and reducing risk of re-identification by making the time, skill, resource, and money necessary to achieve this unrealistic. Now, the different approaches: anonymation, pseudonymation, and differential privacy. There are different routes to making data accessible and shareable within and outside the organization without compromising compliance with data protection legislation and regulations and removing the risk associated with allowing access to personal data. First, differential privacy. Differential privacy source data is summarized and individual personal references are removed. The one-to-one correspondence between original and transformed data has been removed. Anonymation. Identifying data is destroyed and cannot be recovered, so individual cannot be identified. Pseudonymation. Identifying data is encrypted and recovery data token is stored securely elsewhere. These technologies and approaches are not mutually exclusive. Each is appropriate to differing data sharing and data access use cases. Data prevention balance. Perfect data prevention can be achieved by not sharing or making accessible any data irrespective of whether it contains personal identifiable information. Data is unused. Perfect data utility can be achieved by sharing and making Data sharing and third-party access use cases. There are many data sharing use cases and scenarios that involve the sharing potential personal identifiable information such as share data with other business functions within your organization, use third-party data processing and storage platform and facilitate. Use third-party data access and sharing as a service platform and facilities. Use third-party data analytics platform and facilities engage third-party data research organization to provide specialist services. Share data with external researchers. Outsource business processes and enable data sharing with third parties. Share data with industry research partners to gain industry insight. Share data to detect and avoid fraud. Now, data text. We need a mechanism to industrialize and operationalize the implementation of the data prevention. That it proven reliable and secure. That it applied consistently and pervasively. That does not need separate privacy impact assessment and lengthy compliance check before dataset containing personal information can be used. Data privacy by design and by default, pseudomytation and differential privacy are proven technologies that are already in use by large organizations for data sharing while guaranteeing data privacy. Pseudonymization is defined as means the processing of personal data in such a manner that the personal data can no longer be attributed to a specific data subject without the use of additional information provided that such additional information is kept separately and is subject to technical and organizational method to ensure that the personal data are not attributed to an identified or identifiable natural person. GDPR Article 26 is a law. The principles of data protection should apply to any information concerning an identified or identifiable natural person. Personal data which have undergone pseudonymization, which could be attributed to a natural person by the use of additional information, should be considered to be information on an identifiable natural person. To determine whether a natural person is identifiable, account should be taken of all the means reasonably likely to be used, such as singling out either by the controller or by another person to identify the natural person directly or indirectly. To ascertain whether means are reasonably likely to be used to identify the amount of time required for identification, taking into consideration the available technology at the time of processing and technology development. Data attacks. Unlike other attack scenarios, a key concern with data access and sharing arrangement is that the entity being provided with legitimate access to the data is the attacker or the data access control arrangement at the entity are weak. Article 89(1) as a means of enhancing protection in case of further use of data for search and statistics. Article 6(5) as a means of possibly contributing to the compatibility of further use of data. Article 25 as a means to contribute to privacy by design in data application. Article 28 the application of pseudonymization to personal data can reduce the risk to the data subject concerned and help controllers and processors to meet their data protection obligations. The explicit introduction of pseudonymization in this regulation is not intended to calculate any other measures of data protection. Hashing an identifier code. If any of the identity fields contain a recognizable identifier code, then brute force hash attacks are very feasible, even with modest computing resources. Paper is a fixed items of data added to record or field level data before hashing. One possible approach is to use a cryptographically secure pseudo-random number generator to generate salt values such as Fortuna and PCT. Replaces identifying data with a hash code of the data. Input identifying cannot be recalculated Input identifying cannot be recalculated from hash directly. Hash value cannot be recalculated and compared to pseudomite value to generate the original identifying data. Generate a hash token value based on the entire record concerned. This results in a very high degree of variability in the source data for the hashes. Increase the difficulty of identifying the source data that generated the hash code. Hashing and reversibility. The hash of a value is always the same. There is no randomness in hashing. Hashing process as a form of pseudomization is potentially vulnerable to brute force attacks as a large numbers of hashes can be generated very easily and cheaply. Thanks for watching.